What are you looking at? Oh, yourself on the screen right there. Yeah, I see it. Right there, I see it. So for working on the gang lathe, using a tool like this, it's a boring bar, but it's a grooving tool, is awesome because you can fit them all tightly, really close together and get a bunch of different operations tightly. So I've got two different styles here. This is made by Nicole Mini Systems. This is like the brand, and they make a ton of really good inserts with all different sizes and shapes and profiles and widths. So if you're doing miniature grooving and parting off, this is how up there in quality it is, but I think it's pretty good. There's a couple other options out there, obviously, but this is what I've been choosing. So I got the Nicole boring bar, and then I've had this for many years, since my old CNC lathe. This is the parting tool version of it. So whereas, like in the gang setup, this would go sideways, this one would go that way to accomplish the same thing. So I'm going to have to hold it in something like this on the lathe. This guy. So I've got the Nicole one, and then I also bought the Shars version of the exact same thing. Shars doesn't actually sell the inserts, but they do sell the boring bars and these tools as well. And I gotta say, Shars is way cheaper, and the quality is as good or better. I'm actually kind of disappointed with the quality of the legit brand name Nicole tools. I don't like to give negative reviews too often, but when I do, I prefer Dos Equis. No, I shouldn't even say that because I don't drink. I'll show you why though. The first minor thing that bugged me a little bit is that it's got a flat on the top for securing, but it did not have a flat on the bottom because I'm going to mount it upside down. So there's another video I put up. I had Eric surface grind that on the surface grinder and it worked really well. I wish it came with a flat on the bottom. Little nitpicky thing. The Shars one does come with a flat on the bottom. Good for you, Shars. They're otherwise very similar. The Nicole one's a little blacker. I had to grind this relief in it though, because you can see how deep the insert is. It can groove until that step right there. Except from the factory, this would not have allowed a full depth of groove, and I needed the full depth to be able to part off my lock bar stabilizers. So I had to grind this chamfer in there, and I went too far, but it's no big deal. I wish it came with that clearance. The Shars version, oh, I thought it did. The Shars version also doesn't quite go that far. Well, maybe I'm wrong there. Anyway, I like the clearance. Big difference though, check this out. The Shars version has this little support on the bottom, whereas this one does not. And when you put an insert in there, the Nicole version has the insert stick out and be unsupported on the bottom by quite a lot. Whereas the Shars one decided to put a support on there so that the insert is fully supported, which technically would lead to a stronger insert. A little bit heavier cuts, a little bit less chatter, I don't know. And doing something like this is very difficult to manufacture because they had to make it out of a bar that was this big, and they turned everything else away, off center, which is kind of impressive. But the real kicker here, gentlemen and ladies, the Shars one is 10 times cheaper. 10 times cheaper.
10 times cheaper.
I paid $136 for the Nicole one at KBC Tools in Canada. The Shars one is $30, and they same quality, more or less. A little bit different, a couple differences and stuff. And the other thing that bugs me about the Nicole bars, as a milling machinist, you can see on the perimeter here, it's deeper. There's a significant step. And then what happens is when they're milling it and they mill it all out, then they go back and do a finishing pass. The finishing pass often cuts the floor a little bit deeper just because it's recutting it. And that leads to a step right there. So when you're clamping in an insert from the side, the insert is not fully seated against the wall. Now, that's probably not a big deal, but it's just one of those little quality nitpicky things. This is the same way. It's a little bit of a step in there, and it's stupid. The Shars one, while not perfect, doesn't have the step. It's got a bit of step over, their mill was at a tram or something. I'm happy to buy the Shars one because of the price alone. Anyway, so luckily I have all three now, so I can use all three. And I wanted to get one of each so that I could see the quality differences and show you guys the quality differences, but I tell you, if I'm going to buy more, I'm just going to buy the Shars one. Why spend more money for no reason? Okay, one last thing. I will say, in Nicole's defense, they have an excellent selection of inserts. And I will be buying theirs, because Shars doesn't even sell them. But they're good quality carbide, they're well coated, they're sharp, they're really, really sharp. I've got three different kinds here. This is a 1/16 inch straight cutoff tool, a grooving tool, 1/8 inch radius, and then I've also got, these are angled cutters. So instead of being square, they're angled like this, and apparently that's supposed to part off the part without leaving a little nib on the end. I'm sure we'll see that after I make my parts. Quick little other thing, when I'm trying to shim these blocks up, these shims don't fit anywhere very well. You can see these ones I had to put in kind of crooked from the side. Those ones, I was able to get that one straight in, but not two, because you can't fit two side by side around those bolts. And I can't fit them straight in from the side because of the lip in the front. So I don't know if these are supposed to work and they don't, or if there's a better solution to be had. Because I did need to shim this block up to get all the center heights right. Yeah, I don't know if you need a different solution or tweak it or tell me what I'm doing wrong or whatever, but... So I've got my theoretical new setup here for gang tooling for making the spacers. I need 6 tools. I don't really need this one, but I've got it in there anyway. So I've got 7 tools in there and still a little bit more room up top if I wanted to switch things around and add something else. And I could tighten things up. So in a perfect world, I could probably get 7, 8, maybe even 9 tools on the same setup, which is pretty excellent. And eventually Tormach does have the carousel, or not carousel, the turret tool changer that'll go way up in the corner. And that can get you even more tools and still allow you to have probably at least 6 gang tools there. But I'm really enjoying the gang setup right now. When you set up gang tools, you really got to be careful about clearances and stuff. Because let's say I wanted to turn this little nubby and I wanted to use this tool, my tap would hit the spindle. So you have to be aware of where all the tools are and where they might be at all times, and have to be careful not to smash it while jogging it right now. Yeah, even if I took that down to where it should be and brought it over, it would still hit the tap. To fix that, quick and dirty way to fix it is just to extend the boring bar out more. Now I'm pretty sure I read somewhere that a boring bar can stick out 3 times its diameter without any problems at all, without any chatter, deflection, or anything like that. And granted, the cuts I'm making are very light duty. I'm not doing heavy roughing cuts or anything like that. So a 3/4 inch bar should be able to stick out 2 1/4 inches quite easily. So that would be out to there. So I've still got another like 3/4 inch I can stick it out, which might clear and do everything I need it to do. Oh, that's tight. Ow. See what I mean about wanting to have all the tools on the same plane, if you can. That just avoids all these problems. Yeah, it's almost just over 2 inches of stick out. And as I tighten it down, like there's a flat on the top, I'm jiggling it back and forth to find the flat spot, because if you just put it anywhere and crank it down, it will hold it there, but it won't be angled right. So you want to angle it to that flat. So you just keep jiggling and tightening at the same time until you find the sweet spot. Let's see how that works. So yeah, check that out. I could bring that all the way in there, and the tap, it has nowhere to go. It's not going to hit anything. And as I keep seeing guys post on Instagram, if it clears by a millimeter, it might as well be a mile. Because theoretically, the setup should always be the same, and it should just work every time. So I'll stick out these tools as far as well, so I don't have the problem there. Otherwise I'd run into problems right there. So I can't get this tool in there, but I think it's loose, yeah. About like that should do it. But yeah, so I'll try to get them all in the same plane. Except for this guy at the top, which you can't see. So here I have all the tools set up that I want to use. I've got this turning tool in here that I don't need, but it's in there anyway. So I've got my 1/4 inch stock in the collet. To set the stock distance where I want it to be, I put an old spacer on a screw just so I can hold it, and I sort of put it in here and eyeballed it, and said, okay, where do I want to actually machine it from and still have enough room to part it off? So about right there, I guess, is where I want to do. So I'm going to use the end of this tool as a stop. Every time it's done, I can open the collet and push the bar out until it hits that surface. So after the code is done, it's going to park the tool right there so that I can hit that surface and then close the collet. And I've measured the throw of this collet to be about 24 thousandths. You can see how it opens up a little bit right there. So I don't know if that's a repeatable 24 thousandths or what, but it's close enough for now. And as long as you leave a little bit of stock to cut it off as the very first pass. So I figured out where this exact surface is. If I park the tool at plus 40 thousandths of an inch, that gives me 5 or 10 thousandths to part off and clean up on the first cut, and it gives me the throw distance of 24 thousandths, and it should be perfect. So the tool is currently at 40 thousandths, and now it should be a good place to start. So now we go to the computer, if I can figure out how to squeeze in here and film at the same time. You can see with the new milling closure, I don't have a lot of space. It's a good thing I'm a skinny guy. So I figure out where to put the camera. That about works right there. Just put it right in front of me. Here is one of the screens. So whereas the mill runs on Mach 3 for PCs, for Windows systems, this is Mach 3, the program, but Tormach rewrote the whole thing to be based on Linux, and it did their whole interface here, so they made it all basically. So here's the code that I use to run my lock bar stabilizers, all the different tools. And to create a new file, I just went to File, here's my LBS code, copy, I copied it, and then I clicked away, and then I pasted it, renamed it as spacer code. If I double click on it, it opens it up, and then I go back to File, Edit Code, and now I can edit it. Oops. And so the whole PC right now is running on Linux, not on Windows. So there's no menu bar on the bottom. There's nothing else you can actually do on this computer except for run Mach 3 and the text editor right here. But like there's no start menu or options or anything, which is kind of weird, but it's a dedicated PC. That's okay. So when you click Edit, Notepad opens up, but you still have the basic rules of Alt-Tab will go between windows, which is nice, because I like to leave the text editor open sometimes. So I've started rewriting the code for this. So at the top of my codes, I always like to put the current date so I can reference it whenever, and what tools I need. And on the lathe, I'm just getting comfortable with all the tools and what they are, so I'm writing in full detail. Tool 1 is the Nicole grooving bar with 1/8 inch full radius grooving insert. It's mounted above center line, so away from me. It's mounted upside down, and it's the very first one at the top of the gang. And then I'm going in order that the tools are placed on the gang plate. So I'm using 6 tools, and you can see what they all are there. And here's a note that I put in my LBS code for feed rate. So 5 thousandths per rev seems like a decent slow roughing, and then 2,000 seems like a good finishing speed. And I like to put these little notes in parentheses to remind me, and they don't affect the code at all, and it's just a nice little reminder, so I do that all the time. Or if there's something I want to change the next time I run the code, or next month or whatever, I'll put a note in there and say, don't forget to do this, change it next time. So at the top, there's a couple basic codes, G98, G18, G20, kind of forget what they all mean. G30 is home. I don't know if I want that right. Yeah, I guess I want that. So this is my LBS code. I don't need it, so for now, I'm just gonna get rid of it, put it down. And I'm gonna freehand write this code because it's not terribly difficult. It's just a lot of thinking. So here's my part, and I have to figure out all the tools and what they're gonna do. Now it's drilled and threaded, but I think I have the option of drilling and tapping it first, and then doing all the grooving, or I could do the grooving first and then drill it and tap, and then go back in and part it off. And I think for stability of the grooving operations, because I want these to be as exact diameter as I can and consistent, so I'm going to do the grooving first so that there's full bar strength. Grooving first, and then drill and tap, and then go back in and part it off. So to do the grooving first, I guess we can start with doesn't matter what tool we use really. We can start with the 1/8 inch full radius groove in the middle, or we can start with the 2 little shoulders. Shouldn't matter which one, they're just different tools. And I haven't decided yet if I want to put little chamfers on all the edges to break them. Probably at first I won't. I'll just make the part in straight linear lines, no chamfers, no edges, no nothing. Keep it simple. So I'll do that and then I'll catch you up once I'm done. So ideally, at this stage in a machinist's life, you would have a printout with this part in a CAD drawing with like all measurements and diameters and tolerances and lengths and everything. I could go inside and print that off, but I don't see the need right now because I have the physical part and I know all the dimensions, I know what everything wants to be, so I can just kind of eyeball it and know exactly what I want. But a printout would be kind of nice. So on the lathe code, I was reading through my LBS code that I generated with some of the onboard programs and looking at all the G codes, and I was looking at G95 and I'm like, oh, what does G95 mean again? I can't remember. And then of course I remembered the Tormach instruction manual, which is actually fantastic. They did an amazing job. They said they just hired a technical editor that, or technical writer that did a fantastic job writing this out. So they have this whole section on G codes, every single G code that this control software can read. So here's the M95 section. M95 is basically feed per, or units per rev. It'll do like 3,000ths of feed rate per revolution. So every time it goes around, it goes 3,000ths more, around 3,000ths more. Versus on the mill, I usually use feed per minute. So like 10 inches per minute. It's a very linear thing. Whereas on the lathe, you can do it based on RPM, and you can have the RPM change throughout the cut, which is pretty cool. So this is an excellent reference. Keep it handy. All the G codes, all the M codes, lots of examples and like cool things you can do and how to do rigid tapping and all that. We'll get to rigid tapping in a second. Alright, so I spent probably half an hour, maybe up to 45 minutes just kind of looking through this code and figuring it out. I mean, lathe code is relatively simple because it's all pretty much just straight moves and sometimes little arcs. So I basically looked at my part and I looked at my tool and I said, what do I want it to do? So first thing I wanted to do is to just cut the end off, clean it up, and then do this groove, and then tap that surface, and tap that surface, and then cut this groove. And then move to the next tool, the grooving tool, cut that groove, cut, and then move to drilling, spot it, drill it, tap it, and then move back to this tool. This is the angled one. Actually, it'll go like that. And then move back here and cut the end off. Right there. Cut that through the middle. So that's the code that I'm doing right here. And I wrote pretty much all of it by hand. Let's see, so these are the default codes. Start with tool 4. Move to 25. G30 is home position. And a little note for myself. Tool 1. This is feed per rev. I don't know if M98 actually does anything on this controller, but it's in there anyway. G96 means constant surface speed, so the spindle will actually change RPM depending on the diameter of your cut. So D is maximum 2000, S is minimum 600. Those are kind of guesses. I haven't done a G-Wizard calculator on this stuff yet. But just clearance, move to the right Z depth, G1, move to X, to the thickness that I want. So that's basically, looking at my spacer, this is for the groove, so I just kind of went like that. 155, I put it with 156, close enough. Add a feed of 2,000ths per rev, and then slowly retract just a little bit more, and then quickly retract all the way out, and then move out, G30. And just keep doing that. So and you have to choose the workflow that you want. So I know that the full radius groove takes kind of a lot of power and pressure. So I did that first, and then I did the little grooves, and then I did drill and tap, and then I come in and chop it off. So here's my spot code. Now for the spotting and drilling, I went, because I used to mill these on the mill, right? So I went to my old codes for the milling machine and I looked at my speeds and feeds for that, which I know work. For spotting and drilling, I do, I guess, linear feed rate and RPM. So G97 straight up, 2000 RPM, whoopsie daisy. 2000 RPM with a feed rate of 3 inches per minute to a depth of whatever. I don't know if this is going to be good. I'll have to tweak that to get the chamfer that I want. Drill it, I'm going to drill it in 2 passes. Instead of doing a can cycle, I just manually did this. So move to just outside the part, do the first drill at 1.9 inches per minute to 1/8 inch depth, zoom out, zoom back in almost all the way, and then drill again to the full depth, and then zoom out, and then go home. And then the tap, I'll show you the... So Tormach's done a pretty awesome job with their Conversational wizards. So they've got all these wizards here at the top that can generate code for you. So I could turn this part with a radius on it. You've got all your settings here, pretty much every setting you want to do. So OD turn, ID turn, facing, chamfer, grooving, drill and tap, and external threading. This is a code I used to thread my lock bar stabilizers. It worked awesome. You can see all my settings here. So for the drill tap, I went to the drill tap, I clicked on the drill tap button up there, and are these my actual settings? More or less, except for the test I started at 1 inch, whereas actually I'd start at 0. So tool 9, tool clearance of 0.1 inch, spindle RPM 300 RPM, 40 threads per inch, so a 440 thread, basically, and that's it. You hit post, and it works. So I added that. I'm running out of battery here. I just added that entire code to here because I did try it once, and it worked. And it used a G33.1. Simple. It just works. And then angled parting, part it off, and move to the bar load position here at the bottom, like I was talking about before, and then I can butt the bar against that, and then we're good to go. So that probably took me, like I said, half an hour or 40 minutes just to figure out. And this is the first one I've really done by hand. I could do it faster next time, or a program might be able to spit this out faster, but I like the control of just writing it myself. Kind of nerdy like that. So let's see what it looks like real quick before I run out of battery. And that's all it is. It's just a couple lines. There's nothing to it. And these drilling, you can't see them. But those are drills and a couple lines, and I'm not sure if all these make sense. Oh yeah, they should make sense, so I'm going to try it out.